Welcome. In this video, we're going to look at just some base functions that you absolutely need to know in order to kind of be successful when we talk about transformations, and then also this concept of what it means for a function to be even or odd. So the first functions we're going to begin with, you probably have seen already before now, but just so we're clear, you need to know these two in particular, and then every other function family that follows. Okay, so the first base function we're going to look at is the constant function, just looking like something like f of x is equal to a constant c, and if it helps you, instead of having a value c in there, just give it a number, say 4. Okay, but the idea is that if it is a constant function, it means that no matter what x is, y is just c. Okay, so what we would be able to view on the graph is that at a value of c, it is a horizontal line. Okay, that is it. Okay, linear function. We are loving these. We remember that these look like mx plus b. Okay, so again, you would substitute a value in for x, multiply it by m, and then add b. And so the idea with this is that at 0 we would have b, and this is one form of a linear function, but slope-intercept form, we'd have b, and then we'd have m plus b, we'd have 2m plus b. And again, if you want to put numbers in, you sure can. And maybe for now, let's just stick with a basic linear function, just x. Okay, so then if I substitute x in, x is the same as what I have here, so 0, 1, 2, -1, -2, and so this would look graphically like this. Okay, it is a diagonal line of some variety. Okay, and we know it has a slope and intercept and all that good stuff. Quadratic function. Okay, in general, this is going to look like f of x is equal to a x squared plus bx plus c, but our base one that we work with is just going to be x squared. Okay, so let's just concentrate on that. What does that look like? All right, well, if I put in x and squared, it would be 0, 1, and 4. Okay, -1 would square to 1, again, -1 times 1. -2 times itself would be 4. And so what I would see is 2, 3, 4. Just plotting some points quickly. 2, 4, -2, 4, we get something that looks like this. Okay, this shape is called a parabola. All right, next function that we see is a cubic function. So its base graph looks something like x cubed. Okay, again, there could be a squared term, first degree term, and a zero and a constant term too in there. But our base one looks like this. So again, just substituting in 0, 1, 8 for the positives, and then -1 cubed, so that's -1 times -1 times -1 is -1. -2 cubed would be -8. Okay, so again, just quickly sketching here, and I might just do some estimation. So there's our -1, 1, 0, 0, 1, 1, and then 2 is up at 8. So I'm just going to maybe not define my vertical axis beyond here and say it looks something like this. Okay, so that's our basic cubic function. It looks like a snake. Square root function. Okay, this base graph is just f of x is equal to square root of x. Okay, so then again, the domain here, we have to have all x is greater than or equal to 0, so we don't have to worry about negatives, right? But if I go ahead and substitute in 0 for x, I get 0. Square root of 1 is 1, square root of 4 is 2, 9 is 3. And so, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so again, just plotting some things quickly. Okay, I would maybe do a more precise job if I had more time. 4, 2, and 9, 3. I get something like this. Okay, there we go. Cube root function is another one that we should know, just kind of in general what it looks like. Cube root of x. Okay, you could also write this as x to the 1/3. Same thing with the square root. You could write this as x to the 1/2 power. okay? But again, you would just look at a number and try to figure out what number cubed is equal to the input, right? So if I input -8, what number cubed is that? -2, and then -1, 0, 1, and 2. Okay, so for cube roots with odd indexes, you can actually have negatives underneath the radical, and that's okay. 1, 1, 1, 1. So I have 0, 0, 1, 1, -1, 1, and then I'd be all the way out at 8, and then up 2, and then all the way at -8. So I have that point, and I have this point down here. Okay, so I get a sideways snake. Okay. The last two that we need to know are the absolute value function and the reciprocal function. Okay, absolute value looks like just f of x equals absolute value of x. Okay, and again, absolute value is just return positive, so this would be 2, 1, 0, 1, 2 for the y values. And again, just quickly plotting 1, 2, 1, 2, 0, 0, 1, 1, -1, +1, -2, +2, and then 2, 2. And this one you get nice straight lines. This is a V, okay? The parabola, that x squared, is more of a U shape, okay? And lastly is our reciprocal function. This looks like f of x is equal to 1 over x, okay? And here, again, domain restriction, you can't have 0, okay? So reciprocal means just take, if it's in the numerator, put it in the denominator, and vice versa. Okay, so the reciprocal function would give -1/2, -1 still, -2, and then 2, 1, and 1/2. Okay, and so I'm going to do my best to provide a quick sketch. Okay, we know we're at 1, 1, -1, -1. Okay, and then at 2 I'm at 1/2. At 1/2 I'm at 2. Okay, and I actually get something that looks like this. We'll see this function more later in the course, but looks vaguely like that. And again, 1/2, -2, and then 2, -1/2, and something like this. Okay, there are two distinct parts to this reciprocal function. Okay, so in all, take some time to commit these to memory. I would say memorize them. I don't like that phrase, but please make sure to get some time to get these written down. Okay, and with these, you might have noticed that at least in like the absolute value function, we have some symmetry going on, right? Like if we were to fold along the y-axis, that thing would fold on itself. Okay, when we do that, that's a feature of a function that's even. Okay, and so you see the definitions here. We have f of x is even if, and symbolically we would substitute a negative x into the function, we get out just positive x, or positive of the function. So the negative deletes effectively after we simplify. Okay, and then we get symmetry over the y-axis. Okay, odd functions, we go through that same procedure, substitute in a negative x, and then the opposite of the function comes out, meaning all the signs switch. Okay, and graphically what we see is we get origin symmetry. We put our pencil at the origin, spin the graph 180 degrees, and we get the same image. Okay, so then the question I have is, which of these functions is even and which of them are odd? See if you can pause the video and determine that. My answers are in red. Okay, constant is even, cut it along the y-axis and it folds on itself. Odd for the linear function. Cubic function is odd. Quadratic is even. Notice that there's something to do with the exponents too. 1 is odd, 3 is odd, 2 is even. For the square root function, that actually doesn't have any, that isn't even or odd. It doesn't have any symmetry across the axes or about the origin. Cube root function, that's odd. Absolute value function is even, and then reciprocal function is odd. Okay, and so we kind of looked at even and odd from a graphical perspective, but now just to kind of go through the algebra too, how do we determine if a function is even or odd based on its algebraic representation? That's again where we put in the opposite of x, okay? And if I do that, what do I get? Okay, in this case, I get 10 minus the opposite of x squared, right? And then I go through and simplify, okay, this is 10 minus x squared, and if I look at this thing, that's the same as the original function, just f of x, okay? So if I get the same thing back after I substituted in the negative x, then that means that f is even, okay? Something for you to look at with g of x again, put in negative x, what do you get? 1 over 1 minus the opposite of x. If you simplify this, you get 1 over 1 plus x. How does that compare to the original one? Well, negative there, positive there, but then what I'm missing is if I want it to be odd, I would need all the signs to switch, signs on every number in the function. Okay, I'm missing some, right? So this one is actually neither. Okay, I would need all the signs to switch or none of the signs to switch. Okay, lastly, h of x, again, go through, substitute in that minus x, and you get minus x, minus x, and then cubed. Okay, now going through the arithmetic, oops, I already have an equal sign, negative x plus x cubed, okay? Negative x cubed would be negative x, and then, so let me maybe break this down. Negative of a negative x cubed, okay? And then this would be negative x plus x cubed, okay? Which is the same thing as the original function, just with all the signs switched, okay? So that means that h is odd, okay? So we'll see some more examples of this, but other than that, we can determine if a function is even or odd graphically, and again, make sure to commit these uh, eight base functions to memory.